Good evening. So let us look at speed and velocity problems. So speed and velocity, the same techniques of distance and displacement we can use. Distance by time gives speed, displacement by time gives velocity. So let us look at the problems. A body starts moving along a circular path of radius 7 meters. If the boy moves uniformly with 4 meters per second, then his average velocity after half revolution is. So he is going in a circular path of 7 meters. So in half revolution, what is his displacement first? In half revolution, his displacement is 2r, right? That is 14 meters. So if I know, then I can write average velocity is equal to displacement by time. But time is not given directly. They told that what is the distance for half revolution? That is pi r. That is 22 by 7 into r is 7 meters, so 22 meters. He is moving with a speed 4 meters per second. So what is the time taken to cover a distance of 22 meters with a speed of 4 meters per each second? That is 22 by 4. That is 11 by 2 seconds. So his velocity, average velocity can be found as V bar is equal to 14 by 11 by 2. That is 28 by 11 meters per second. Right? So average velocity is 28 by 11 meters per second. Here time you have to find from the definition of speed. If time is directly given, it is a direct question. Next 47. A boy travels 5 kilometers eastwards, 4 kilometers northwards, and then 2 kilometers westward. It takes 2 hours for this journey. The magnitude of average velocity of the boy is. So time is given. I need to find displacement. How to find displacement? I can take the help of vectors. So OA bar is 5i cap, OB bar is 4j cap, OC bar is minus 2i cap. So total S bar is equal to 5i minus 2i, 3i plus 4j. That is magnitude is 5 kilometer. So displacement is 5 kilometer, time is 2 hours. So average velocity is 5 by 2, 2.5 kilometer per hour. Right? Next. A body travels towards north with a velocity of 20 meters per second for 20 seconds and then moves towards east with a velocity of 3 meters per second for 10 seconds. Its average velocity is. So this is 48th question. So 48th question. A body travels towards north with a speed of 2 meters per second for 20 seconds. That means it travels 40 meters towards east. And 3 meters per second for 10 seconds. That means 30 meters towards east. So this is 40j cap, this is 30i cap. So what is displacement? So displacement is equal to 40j plus 30i. That is magnitude is 50 meters. The time is 20 seconds and 10 seconds, so 30 seconds. So average velocity is equal to displacement by time. So 5 by 3 meter per second. Right? You have to use the vectors. The speed is given, speed into time gives the distance. The next question, a car starts at one vertex of a square track of side 125 meters and reaches the starting point in 50 seconds. Find the speed of the car. It is going in a, so it is going in a square track and length of each side is 125 meters. So total perimeter is 4 into 125. So 500 meters. 500 meters it is covering in 50 seconds. So the average speed is 500 by 50. So 10 meter per second. Right? Next question. During a journey, a car travels with speed 20 km per hour for first 1 hour, with a speed 25 km per hour for next 2 hours. Find the total distance. This is V1 T1 plus V2 T2. Distance is, so 20 into 1, 20 km, 25 into 2, 50 kilometers. So total distance is 20 plus 50, 70. Right? Next. A car travels in a circular path of radius 7 km at 44 km per hour for 1.5 hours. Find the distance and displacement of the car. Distance is straightforward. They have given speed and time. So V into T gives distance. 44 into 1.5. In 1 hour it will go 44 kilometers. In half an hour it travels another 22 kilometers. So 44 into 3 by 2 is 66 kilometers. Then how to find displacement? Look at the 51st question. So distance we got 44, speed into time, that is 66 kilometers. Because it is going in a circular track, I need to find what is the circumference of that circular track. Circumference is equal to 2 pi r. R they have given 7 kilometers, so 2 into 22 by 7 into 7. So it is 44 kilometers. That means 66 kilometers means how many rounds are finished? Number of rounds is equal to distance by circumference. So 66 by 44. That is 1.5 round. So 1 round finished means displacement 0. In half round, what is displacement? So half round displacement is 2r. So 14 kilometers. So from circumference, distance by circumference gives number of rounds finished. From that one, we can find the how many what fraction of round is completed. So from that fraction, we can find displacement. Right? So 66 and 14 kilometers. Next question also, same model. A car goes around circular path of radius 14 kilometers at a constant speed of 22 km per hour. Find the distance and displacement of the car at the end of 5 hours. So 5 into 22, 110 kilometers distance. For displacement, you write 2 pi r. Previously you got for r is equal to 7, 44. So 14 kilometers means 88. 110 by 88 means it is 5 by 4, 1/4 of a round. 1/4 of round means displacement is quarter circle, r root 2, that is 14 root 2. Here it is a printing mistake, 110. This is not 14, 12, it is 14 root 2. Okay. Second option, 110 and 14 root 2, that is. Next one also, same model. A car moving with a constant speed of 10 meter per second covers 2 rounds of a circular track in 10 seconds. Find the radius of circular track. Here, what is the distance covered? 10 meter per second. Each second it is traveling 10 meter. In 10 seconds it travels 10 into 10, 100 meters. So it is finishing 2 rounds. That means what is the circumference? 4 pi r. So 4 pi r is equal to 100. Then r is equal to, so this is 53. 4 pi r is equal to 100. So r is equal to 25 by 5. because one round is 2 pi r, 2 rounds is 2 into 2 pi r. Next, a car travels from station A to B at 30 km per hour and then back to A at 70 km per hour. Find the average speed and average velocity of the car. Average velocity because it started from A and it reached A again, so 0. For average speed, is it equal times or equal distance? A to B and B to A, same distance. So equal distance case, you have to write 2V1 V2 by V1 plus V2. So 2 into 30 into 70 by 30 plus 70 is 100. So 3 into 721 into 2, 42. So 42 km per hour and 0. Because displacement is 0, na? Okay. Next, a man travels with a speed of 30 km per hour for first half of the journey time and with a speed of 70 km per hour for the next half of the journey time. Find the average speed of the man. So it is equal times. Equal times means V average is equal to V1 plus V2 by 2. So 70 plus 30 by 2, that is 50 km per hour. Right? Equal distances is 2V1 V2 by V1 plus V2. Equal times is V1 plus V2 by 2. A car travels at a speed of 120 km per hour for 1 hour and halts for half an hour and then resumes the journey with speed of 100 km per hour for the next 1.5 hours. Find the average speed. First, we have to find the distance. So, first distance is V1 T1, 120 into 1, 120 km. Second speed, halts means it stops. So, second time, the distance is 0. Third time, 100 km into 1.5 hour. That is 100 into 1.5, 3 by 2. That is 150. So total distance is 120 plus 150, 270. Total time is 1 hour plus half an hour and 1.5 hour, 3 hours. 270 by 3. So 90 km per hour. Average speed is, so V1 T1 plus V2 T2 plus V3 T3 by T1 plus T2 plus T3. The same formula. A boy travels with speeds V1, V2 and V3 for 3 successive time intervals which are in the ratio 1:1:2. Then the average speed V1 T1 plus V2 T2 plus V3 T3 by T1 plus T2 plus T3. That means V1 plus V2 plus 2V3 by 1 plus 1 plus 2. That is 4. That is second option. V1 plus V2 plus 2V3 by 4. Right? Next one. A boy travels with speeds V1, V2, V3 for the 3 successive time intervals which are in the ratio 1:2:3. So 1 into V1 plus 2 into V2 plus 3 into V3. That is V1 plus 2V2 plus 3V3 by 1 plus 2 plus 3. That is 6. Right? This is the formula V1 D1. Total distances by total time. Distance is V1 D1. Yesterday we discussed about the formula. Next one is somewhat tricky. From next one onwards, you have to apply double. A car travels from station A to station B at 30 km per hour. During its return trip to A, it travels at 30 km per hour for first half distance, 70 km per hour for next half distance. Find the average speed of the car. Here see, there are 3 types. It is going from A to B, 59. This is not direct formula, a little bit extension of the logic. They are saying from A to B, it is going at 30 km per hour. In the return journey, first half distance it is going at 30 km per hour. Next half distance it is going for 70 km per hour. So there are 3 velocities, V1, V2, V3. Right? Data is right now. So 30, 30, 70, equal distances, half of distance. So can I redraw this diagram as I'm going from A to B? Well, let us call this V1, that is 30 km per hour. Because from B to A, distances are equal. If I call V2 and V3, I can say the average velocity V4 is equal to 2v2 v3 by v2 plus v3, because equal distances it is traveling. That means 2 into 30 into 70 by 30 plus 70, that is 42. Already we have seen. Now v1 and v4 are again equal distances, because it is going average speed a to b with 30, b to a with 42. So I can write v average is equal to 2v1 v4 by v1 plus v4. So 2 into 30 into 42 by 30 plus 42 is 72. This is 36 times. This is 5 and 6 again, 7 again. So 5 7s are 35 kilometers per hour. Okay. So twice you have to apply. Instead of distances, if they say times, I could have taken V4 is equal to V2 plus V3 by 2. Instead of 42, I might have got 50. Then again, I have to take 30 and 50 are equal distances. A to B, B to A same. Right? అర్థమైందా ఇది? 60. A car travels from station A to station B at 30 km per hour. During return trip to A, it travels at 30 km per hour for first half of journey time and 70 km per hour for next half of journey time. The same thing we discussed. So 30 and 70 gives 50. So 2 into 30 into 50 by 30 plus 50, 80. That is 37.5 we will get. So 37.5 km per hour and 0. The same question with times equal. That means V4 becomes V2 plus V3 by 2. Okay. Next one, the same question. A car travels with speed V1 for the first half of the journey distance. During the second half of the journey distance, it travels with speed V2 for the first half of the time and with speed V3 for the remaining journey time. Find the average speed. Let us draw the diagram for 61. They told that it travels first half of journey distance with V1. Then second half equal times they told V2 and V3. So I can write V4 is equal to V2 plus V3 by 2. Now V1, V4 equal distance. Now this is D by 2. This is also D by 2, B to C. So I can apply V average is equal to 2V1 V4 by V1 plus V4. That is equal to 2 V1. V4 is V2 plus V3 by 2 by V1 plus V2 plus V3 by 2. If I take 2 LCM, 2 will get cancelled. This becomes 2V1 times V2 plus V3 by 2V1 plus V2 plus V3. Right? So 2V1, V2 plus V3 by 2V1 plus V2 plus V3. Next question. A car travels with speed V1 for the first half of the journey time. During the second half of the journey time, it traveled with speed V2 for half the distance, with speed V3 for the remaining journey time. So V2, V3 are equal distances. So V4 is equal to 2V2, V3 by V2 plus V3. Now you have to take V1 and V4 are equal time. So V1 plus V4 by 2. That is, you will get V1 plus 2V2, V3 by V2 plus V3 by 2. That means V2 plus V3, if you take LCM, you will get V1 times V2 plus V3 plus 2V2 V3 by 2 times of V2 plus V3. First option you will get. Right? The same logic you have to extend. Next question. The length of a hill slope is 200 meters. A boy starts at the foot of the hill at 10 a.m. Traveling for 1 hour, he relaxes for half an hour and finally reaches the hilltop at 2 p.m. He takes rest for an hour. He resumes journey at 3 p.m. and reaches the foot of the hill at 4 p.m. Find the average speed for upward journey, downward journey. For upward journey, he is covering, because answers are in kilometer per hour. So I will convert 200 meters into 0.2 kilometer. So 0.2 by how much time they have taken? They started at 10 and ended up at 2 p.m. That is 4 hours. So 0.2 by 4, that is 0.05. Downward journey, 0.2 by, he started at 3 and reached at 4, 1 hour. So 0.2 by 1, that is 0.2. So 0.05 comma, that is comma, 0.2, fourth option. Fourth option is 0.05 comma 0.2. Right? 64th. A person walks a distance 30 meter along west with a speed of 2 meter per second and 40 meters along north with a speed of 4 meter per second. Find his average speed and average velocity. From the graph itself, we can say the displacement is 50 meters, 30, 40, right angle triangle. What is the time we need? 30 meter with 20 meter per second. That means distance by speed gives time. That is 15 seconds first one. Second one, 40 meter by 4 meter per second, 10 seconds. So speed is 70 by 25. Displacement is 50 by 25. So 2.8 meter per second and 2 meter per second. Right? Next question. A body is moving along a regular hexagonal path as shown in figure. Find the average speed and average velocity of the body from A to D. Let us discuss about this problem. So he is going in a regular hexagon. That is 66th problem. Huh? Okay. So for regular hexagon, what is this diagonal? If it is A and this is A, you can say this is 120 degrees. The displacement is root 3A. Right now? This one is, this is root 3A and A. This is 90 degrees. Then it is 2A. Again, A to E is root 3A. Other diagonal length is root 3A. Main diagonal length is 2A. Is going with speed V. So A to D, they want average velocity. So V bar is equal to displacement, that is 2A by time. What is the time taken? If you are going with a speed of V, constant speed, the time is distance. What is distance? AB plus BC plus CD, that is 3A. 3A by V. So V bar is equal to 2A by 3A by V. That is A will get cancelled, so 2 by 3V. Suppose if I am taking A to E, then displacement is root 3A. Time is, because the distance will become 4A, 4A by V. If I go from A to F, from AB to F, then it is 5A by V. Time will vary, the displacement also varies. Okay? Depending on which corner you are going, you have to use this one. Other diagonal is root 3A. Main diagonal length of a regular hexagon is 2A. You should know this one to answer these type of problems. Okay. Next one. A body is moving along a circular path of radius r and it takes t seconds for a complete revolution. Find the ratio of average speed and average velocity by 3t by 4. Average speed and average velocity times are equal. So distance by displacement. 3t by 4 means 270 degrees. What is distance formula? 3 pi by 2 r, no? T by 4 means 3 pi by 2 r, and displacement is, average velocity means displacement is 2 r sine theta by 2. That is, it becomes root 2 r. So take the ratio at 3t by 4. No? So 66 V by V bar is equal to, you can write displacement, distance by displacement. Distance is r theta, r into theta is 3 pi by 2, 3 by 4 seconds. While it is displacement is 2r sine 270 half means 135. So r will get cancelled. Sine 135 is root 2, we will get 3 pi by 2 root 2. Right? Next one. A man walks on a straight road from his home to a market 2.5 km away with a speed of 5 km per hour. Finding market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. What is the magnitude of average velocity, average speed of the man over the interval of time? 0 to 30, 0 to 50, 0 to 40. First, we have to find where he ends up. He's starting from his home. 0 to A. He's going at 30 kilometer per hour, 5 kilometer per hour. The distance is 2.5 kilometers. He's going at 5 kilometer per hour. That means in 30 minutes, where he end up? So what is the time to go from O to A? T is equal to distance by speed. That is, distance is 2.5 kilometer. He is going at 5 kilometer per hour. That means it is half an hour. That means 30 minutes. Because when he is going from 0 to A, the distance and displacement are same. So velocity is 5 kilometer per hour. Speed also 5 kilometer per hour because it is a straight line. Both are same. Then he finds that it is closed and he travels back with 7.5 kilometer per hour, right? So return journey, what is the time taken? T2 is equal to distance by speed again. That is 2.5 by 7.5 hours. That is 1/3 of an hour. That is 1/3 of 60 minutes means 20 minutes. That means at 50 minutes is exactly at 0. That means average velocity 0, displacement 0. So V average here is, because equal distances, I can apply 2V1 V2 by V1 plus V2. So 2 into 5 into 7.5 by 5 plus 7.5 is 12.5. This is 3 times. This is 5 times. So 6 kilometer per hour. So when 0 to 50 minutes, he is having average velocity 0, and 0 to 40 minutes. That means 0 to 30 will go forward. Exactly halfway he will be there. That means 1.25 kilometers. That means displacement is 1.25. So time is 40 minutes means 2 by 3 hours. So average velocity is displacement by time, that is 1.25 into 3 by 2, that is 3.75 by 2, 1.875 kilometer per hour. For speed is, that is 2.5 plus 3.75, 1.25, that is 3.75 by 2 by 3. So speed is 3.75 by 2 by 3. That is 3 5s are 15, 7 3s are 21 plus 1, 22. 3 3s are 9, 11.25 by 2. That is 5.625 kilometer per hour. So these options are so first one 5 kilometer per hour, 5 kilometer per hour. Second 0.6 kilometer per hour. Third 1.875, 5.625. So first option. This is your NCERT textbook question. Next one, a particle starts moving along x-axis with constant velocity 4 meters per second. After 2 seconds from the start of the motion of the first particle, another particle starts in the same direction with same position with constant velocity of 6 meters per second. Calculate the time at which second particle will catch the first particle. So let us take first particle started at 4 meters per second. So it has to travel a distance of d. This is 68. So time, if I take t, 4 into t should be equal to, second one is traveling after 2 seconds. That means time of journey of second one is t minus 2. Na? So the distance traveled by second one is 6 into t minus 2. So they have to meet means they have to travel the same distance. So 4t is equal to 60 minus 12. So if you write tt will get cancelled, t is equal to 12, that is 2t is equal to 12, t is equal to 6 seconds. So the second one catches the first one after 6 seconds. 69. Two trains P and Q moving along parallel tracks with same uniform speed of 20 meters per second. The driver of train P decides to overtake train Q and accelerates his train at 1 meter per second. Accelerates at 1 meter per second square. After 50 seconds, the train passes the engine of the train Q. Find out what was the distance between the two trains initially, provided the length of each train is 400 meters. So both are traveling with 20 meters per second. So what is the distance traveled by first train? S1 is equal to Vt because it is going with constant speed, or Ut, initial velocity. So what is the initial velocity they have given? They are traveling with 20 meters per second for 60 seconds or 50 seconds. 50 seconds after it catches. So 20 into 50. So first one travel 20 into 50, 1000 meters. Second one travel, because it is accelerating, you can write ut plus half at square. That means 20 into 50 plus 1 by 2. A is 1 meter per second square. T square is 2500. So 2250. So what is the distance between them? S2 minus S1 is 1250. If they are point masses, I can say initially their distance is 1250. But the trains are having length of 400 meters and second train will have 400 meters. So what is the distance between them? Out of 1250, I have to subtract this 800. Na? So that is 450 meters. Right? Out of this 1250, the length of train should be subtracted. Right? It is 450 meters. So next, a car travels with speeds v, 2v, 3v, so on up to nv for successive time intervals which are in the ratio 1:2:3, so on up to n. Find the average speed of the car. What? How to find? v1 t1 plus v2 t2 plus v3 t3. That means 1 into 1v, 1 square, 2 into 2v, 2v, 2 square v, 3 square v. So v average is equal to 70th. So V average is equal to V times 1 square plus 2 square, so on up to n square, because V into T. Times are in the ratio 1:2, that means 1 plus 2 plus 3 plus so on up to n. So what is sum of squares of first and natural numbers? N of n plus 1 of 2n plus 1 by 6. Sum of squares, sum of first and natural numbers, that is n of n plus 1 by 2. So n plus 1, n plus 1. 2. So that is 2n plus 1 by 3 times v. Right? Next question. A boy travels with speeds v, 2v, 3v, so on up to nv during successive journey distances, which are in the ratio 1:2:3:n. Find the average speed of the boy. So distances are given. What I have to write? Distance is 1 plus 2 plus 3 plus so on up to n. By times are distance by speed, na? 1 by v, 2 by 2v, 3 by 3v. That means I will always get 1 by v, 1 by v plus 1 by v, so on up to n. So it becomes n by p. So 71. V average is equal to write d1 plus d2 plus so on up to dn by d1 by v1 plus d2 by v2 so on up to dn by vn. So they have given d1, d2, d3 are distances are 1:2:3. So we'll add them. 1 plus 2 plus 3 plus so on up to n. Here times d. Here distance if you take d by 1d by 1v. We'll write the next. So we have to write 1 plus distance are 2 plus 3 plus so on up to n times d. So it is d by 1d by 1v, 2d by 2v times 3d by 3v. That means I will have d by v all. D anyhow it will get cancelled. So it becomes this is n of n plus 1 by 2 times d. Denominator is n times d by v. So dd will get cancelled, n will get cancelled. So n plus 1 by 2 times of v. Right? So any doubts in this one? So if there are no doubts, we can move on to next questions. A little bit of introduction about equations of motion. Then we can look at the equations of motion questions also. So what is equations of motion? From definition of acceleration, what is acceleration? Final velocity minus initial velocity by time. So v is equal to u plus at. This is first equation of motion. Then second, displacement is equal to, let us take the simple example. If I am going at 10 meter per second for 10 seconds, how much distance I will travel? 100 meters. Suppose I am going with 20 meter per second for 10 seconds, then I will go 200 meters. Now, I started my journey with 10 meter per second. Each second it is becoming, after 1 second it is becoming 11, 12, 13, 14. Finally, after 10 seconds it becomes 20. So if I am going at 10 meter per second for 10 seconds, I am going 100 meters. 20 meter per second for 10 seconds, I am going 200 meters. If I start with 10 and end up with 20, then my distance will be in between 100 and 200. It will be 150 meters. So how to write? That is actually average velocity into time. The average velocity means u plus v by 2 into t. It can be applied when the acceleration is uniform. The condition is acceleration is uniform, then you can write s equal to average velocity into time. From this one, when you write v is equal to u plus at, you will get s equal to ut plus half at square. So if you observe here, so this is ut. This 50 meters is half at square. So you will get that out. If I take vt, then it should be vt minus half at square. So if you write in terms of v, so v u in terms of v, that is v minus at, u is equal to. Then you will get s equal to vt minus half at square. If you write initial velocity, you will get ut plus half at square. If you write final velocity, it is vt minus half at square. Then another formula is, if you eliminate t here, you will get v square minus u square is equal to 2as. So these are the equations of motion. Then what is the distance traveled in nth second? What is the meaning? So if I start my journey in n seconds, Sn, I will travel some distance. What is the distance traveled in only n second? Then I have to subtract what is the total displacement, a distance traveled in n minus 1 seconds. No? So this equation is total displacement in n second is nothing but total displacement in n minus 1 second plus displacement in nth second, Sn. So Sn is equal to total displacement in n seconds minus total displacement in n minus 1. So in place of t, if you take n, un plus half a n square, and this one you will get final formula as u plus a by 2 of 2n minus 1. The distance traveled in nth second. If you observe, when u is equal to 0, s1 is equal to a by 2 because n is 1, 2 minus 1. s2 is equal to 2 2s are 4, 4 minus 1, 3a by 2. s3 is equal to 5a by 2. Then, so I can write s1 is 2, s2 is 2, s3, so on up to Sn is equal to 1 is 2, 3 is 2, 5 is 2, so on up to 2n minus 1. Right? Any doubts in this one? These equations are fine. It is okay, we can go for problems. So in these problems, mostly this third Roman and fourth Roman are easy. Fifth Roman is somewhat critical. Sixth one also is easy. So let us go through it fast. Wherever you are having doubt, you can ask. The speed of a body moving along a straight path changes from 5 meter per second to 10 meter per second in 5 seconds. Find the acceleration of the body. So final velocity is 10 meter per second. Initial velocity is 5 meter per second. Change in velocity is 10 minus 5, 5 in 5 seconds. So 5 by 5, 1 meter per second square. Right now, acceleration is v minus u by t. The second one, the speed of a body moving along a straight path decreases from 10 meter per second to 5 meter per second. Here, final velocity is 5 meter per second. Initial velocity is 10 meter per second. So, v minus u gives minus 5 by 2. That is minus 2.5 meter per second square. When they told that deceleration, automatically negative sign is there in the definition itself. So, you can give the magnitude. Deceleration is minus a. So 5 by 2 is 2.5 meter per second square. A vehicle is moving along on a straight level road with constant speed 10 meter per second. Due to application of brakes, it comes to rest in 5 seconds. The deceleration is. It comes to rest is final velocity 0, 10 by 5. That is 2 meter per second square. That is the deceleration. And as it takes 2 seconds to reach its maximum speed of 18 km per hour. Then you have to convert the unit. 18 km per hour means 18 into 5 by 18 meter per second. So 5 meter per second. What is the magnitude of his average acceleration? That is 5 by 2, 2.5 meter per second square. Two racing cars acquire velocities of 18 km per hour and 36 km per hour in 0.5 seconds. If they are accelerated uniformly from rest, find their accelerations. So initial speed is 5 meter per second. Second one is 10 meter per second. Here, they are starting from rest. U is 0. Final velocities are 5 and 10. Two cars are there. Na? So A1 is equal to 5 minus 0 by 0.5. That is 10 meter per second square. Second one, 10 minus 0 by 0.5. 20 meter per second square. You should not write 10 minus 5. 10 and 5 are related to two different cars, A1 and A2. Find the acceleration of cheetah if it acquires the velocity of 135 km per hour within 2 seconds after the start. So initial velocity 0, you have to convert this 135. So what is the question? This is 77. Let us calculate. Because the ratio is in fractions only. It's 77. Huh? So it is reaching 135 km per hour. 135 into 5 by 9, 5 by 18. So 9 will get 15 times. So this is 75 by 2. Time they told 2 seconds. So acceleration is equal to v minus u by 2. So 75 by 2 by 2 because that is 0. So it is 75 by 4 meter per second square. Right? conversion. Then an ostrich can acquire a velocity of 144 km per hour in 2 seconds, while a leopard can acquire a velocity of 108 km per hour in 3 seconds. Find the ratio of their velocities. 5 by 18 means 18 is 6 times, so leopard will be 30, ostrich is 40. 144 means 18 is 8 times. So it will be times are equal. You can simply write 1. So 144 by 2, this is 108 by 3. Find the ratio, then you will get the answer. 72 by this is 54 or 36. That is 2:1. You don't need to convert because both conversions will get cancelled. A car is moving with a velocity of 30 meters per second, subjected to a uniform retardation of 3 meters per second square. The time taken by the car to come to rest. Come to rest means final velocity 0. So you can write A is equal to B minus U by T. So T is equal to B minus U by A. So 30 by 3, 10 seconds it will take. A bus is moving with a constant speed of 75 km per hour. The driver observes the red signal and applies the brakes. The speed of the bus reduces uniformly to 21 km per hour in 3 seconds. So what is the change in velocity? 54 km per hour. Then you can convert 54 into 5 by 18. That is 15. 15 by 3, 5 meters per second square. Retardation produced is 5 meters per second. Here see, initial speed is that 20 meters per second, final speed also 20 meters per second. But because it is taking a turning, that means it is going in opposite direction. The final velocity is minus 20 meters per second. So what is the acceleration? Look at the 80 first. So acceleration is equal to, you have to take with sign. 80 first. Acceleration is v minus u by t. V is minus 20 because it has taken left turn, U-turn. Going forward, we have taken positive, going backward negative by 20 seconds. So it is minus 2 meters per second square, the retardation. Right? Next is the speed of a body which is moving with a constant acceleration changes from 5 meters per second to 15 meters per second in 5 seconds. Find the displacement of the body. So they have given v and u and time. So average velocity into time gives displacement. The equation you have to use is S equal to u plus v by 2 into t. So u plus v is 20 by 2, that is 10 into 5, 50 meters. Right? Next one, a body moving with acceleration covers a displacement 5 meters in 2 seconds. Find the velocity after 2 seconds if its initial velocity is 1 meter per second. Same, SC is 5 meter per second. So 83 is also, how to write? S equal to u plus v by 2 into t. So yes, they have given 5 meters, u 1 meter, v I have to find by 2, t is 2 seconds. So 2 will get cancelled, v is equal to 4 meters per second. Right? Next is, a uniformly accelerated car is found to possess the velocities 12.5 meters per second and 135 km per hour at 2 different places in its path. If the car takes 10 minutes to travel between these places, find the distance between them. So you have to convert V 135. Just now we have done 135 into 5 by 18, that is 75 by 2, that is 37.5. So U plus V is 12.5 plus 37.5, it is 50. 50 by 2, 25. 25 into 10 minutes means 10 into 60. So 25 into 600. How much you will get? 15 kilometers, na? 25 600 is 150. So 15,000, that is 15 kilometers. A cyclist moving with an initial velocity 4 meters per second is uniformly accelerated at 3 meters per second square. Find the distance traveled by the cyclist in 6 seconds. So S equal to ut plus half at square. Ut is 4 into 6, 24. Half at square is half. A is 3 by 2 into 36. That is 18 into 3. 54 plus 24, 78. Just you have to write ut plus half at square. A racing car starts from rest, moves with constant acceleration. If it crosses the end point of first lap after 160 minutes with a velocity of 180 km per hour, and find the length of the lap. Initial velocity 0, final velocity 180 into 5 by 18, that is 50 meter per second. So 50 plus u plus v, that is 0 plus 50 by 2 into 160 minutes, 160 into 60. Whatever the calculation. So S equal to u plus v by 2 into t. You have to convert units to the calculation. An express train starts from one station. After 40 minutes, it crosses a small station which is at a distance 30 km. Find the velocity of train when it crosses the station. So this is also same. S equal to u plus v by 2 into t. U is 0. Time is 40 minutes, 40 into 60. Distance is 30 kilometers, 30,000. So from that one you can find v, right? So 30,000 is equal to u is 0. V by 2 into 40 minutes is 40 into 60. So write that one, you will get the answer. The brakes of an automobile can produce a constant deceleration of 2 meters per second square. After application of brakes, the vehicle comes to rest in 9 seconds. Find the stopping distance. Here, you can take final velocity 0. So I can write S equal to Vt minus half a t square. A is minus 2 already. So half a t square, it will be 81 meters. T square is 81. Na? You can use Vt minus half a t square. That will give the answer quickly. Then the brakes of an automobile can produce a constant deceleration of 3 meters per second square. Find the maximum distance traveled after application of brake if it comes to rest in 6 seconds. This is also same. Vt minus half a t square. Vt is 0. Half a t square is 1 by 2 a t square, that is 18 threes, 54 meters. Next one. A particle having a velocity of 4 meters per second is accelerated at a rate of 1.2 meter per second square for 7 seconds. Distance traveled during the period of acceleration. S equal to ut plus half a t square. So ut is 7 into 4, that is 28, plus half a t square. Half a is 0.6 into 49. Calculate that one. Maybe 57.4, whatever you are getting. A person traveling at 43.2 km per hour applies brakes, giving a deceleration of 4 meters per second square to his car. Find the distance traveled by the car before it comes to rest. Here they have given initial velocity, final velocity is 0. Acceleration we know. How to find displacement? V square minus u square is equal to as. Because a is given, s I have to find. So s equal to, convert 43.2 into 5 by 18, then substitute the value. V square by 2a, you will get that one as s. Due to application of brakes, which produces a uniform deceleration of 4 meters per second square, a car comes to rest in 50 meters. The initial speed of the car is. So, what you have to use? They have given distance. Initial speed we have to find, final speed 0. So again, v square minus u square is equal to s. A bullet moving at 35 meters per second penetrates 2.8 meters in a wooden plank, comes to rest. Assuming uniform retardation, find the time of penetration of the bullet. So s is 2.8, final velocity 0, initial velocity I know, time I want to find. S equal to u plus v by 2 into t. Right? S equal to u plus v by 2 into 2. S is 0.8, v is 0, v is by 2 into t. From top of a school building, a boy drops a marble. It falls on a heap of sand and comes to rest after traveling a distance of 135 centimeters in 0.15 seconds. Find the velocity of marble. Find the velocity of marble at the time of striking the heap. So, S equal to u plus v by 2 into t. So u is final velocity becomes 0. I have to find u. 135 centimeters, take 1.35. That is equal to v by 2 into 0.15. A uniformly accelerated bus passes over a straight bridge of length 4.2 km. With what velocity should bus enter the bridge in order to leave the bridge with velocity of 29 meter per second in 4 minutes? This is also same. S equal to u plus v by 2 into t. You don't know u, v they have given. So t 4 minutes, 4 into 60. A car traveling at 15 meter per second comes to rest due to application of brakes that produces a deceleration of 5 meter per second square. The stopping distance is. So v square minus u square is equal to 2a. V is 0. U square by 2a gives the s value. Okay. So these are direct formulas. This fifth Roman is somewhat requires the application of concept a little bit more. So let us go for sixth Roman first, because it will be finished in 10 minutes, less than 10 minutes. Then we will go for fifth Roman final. The sixth Roman is single formula Sn equal to u plus a by 2 of 2n minus 1. So we'll finish that one first. Sixth Roman starts at 112. From 112, a body starts from rest and moves with an acceleration of 2 meter per second square. Find the distance traveled by body in 5 seconds. So what is Sn? A by 2 of 2n minus 1. Na? So a by 2 of 9. 9a by 2 means that is 9 meter only, because a is 2, a by 2 is 1. So 9 meters. A car starts from rest and moves with an acceleration of 6 meter per second square. Find the distance traveled by the body in 12 seconds. So again Sn. Sn is equal to u0 they told. So a by 2 of 2n minus 1. That is which question? 113. 113. Yes, 12 we want. Yes, 12 is a by 2 of 2n. 2 12s are 24 minus 1, 23. So 6 they have given, 6 by 2 into 23. That is 3 into 23, 69 meters. Right? A car is accelerated at 4 meter per second square, has a velocity of 10 meter per second, and it crosses a lamp post. Find the distance traveled by the car in 8 seconds after crossing the lamp. Sn, S8 is equal to u plus, u is 10, a by 2 of 2n minus 1. A is 4, so 10 plus 2 into 15, 30 plus 10, 40 meters. A bus having an initial velocity 3 meter per second is accelerated at 6 meter per second square. Find the distance traveled by bus in 5th second after crossing the lamp post. So S5 is equal to u plus a by 2 of 2n minus 1. 9 3s are 27, 27 plus 3, 30. These are direct only. A body has started from rest and is accelerated uniformly. The distance covered by the body in first 3 seconds is equal to the distance traveled by it in last second. Find the time of journey. This is somewhat tricky. The distance covered by the body in first 3 seconds, that is total displacement in 3 seconds, is equal to distance traveled by it in the last second. So I can write 116. It says total displacement in 3 seconds is equal to distance traveling in second. What is distance traveled in first 3 seconds? Because it starts from rest, half a t square. T square is 9. Is equal to a by 2 of 2n minus 1. So a by 2 will get cancelled. 2n is equal to 10. So n is equal to 5 seconds. Right? So total displacement in 3 seconds is equal to distance traveled in n second. Next one. Which one we are doing? 114. A car which is accelerated at 4 meter per second square has a velocity of 10 meter per second. When it crosses a lamp post, find the distance traveled by it. That is over now. 116 we finished. 117. A body has started from rest and accelerated at 4 meter per second square. The distance covered by the body in first 7 seconds is equal to distance traveled by it in the last second. That is same. S7, that means half AT square. A by 2 of T square means 49 is equal to A by 2 of 2n minus 1. So n is equal to 25. So now you have to find the distance traveled by the body is S equal to U is 0, half AT square. 1 by 2 A2 into T square. T square is 25, 625. 625 into 2, 1250, 1250. A particle starts from rest and is accelerated uniformly. Find the ratio of distances traveled by it in third and fifth second. S3 is to S5 is, when n is 3, it is 5 is to 9. Right now, 2n minus 1 is 2 3s are 6 minus 1 5. When 5, 2 5s are 10 minus 1 9. S8 and S5, that means 16 minus 1 15 is to 10 minus 1 9. 15 is to 9 means 5 is to 3. A body starts from rest and is accelerated uniformly. Find the ratio of distances first, second, and third. S1 is to S2 is to S3 are 1 is to 3 is to 5. The body starts from and accelerates. Find the ratio of distances traveled by it in first, third, and fifth second. First, third, and fifth. Then that is S1 is to S3 is to S5. That means 1 is to 5 is to 9. You have to skip 3 and 7. Na? If S1 is to S2 is to S3 is to S4 is to S5 is 1 is to 3 is to 5 is to 7 is to 9. Odd numbers. 112. A particle is moving along a straight line with Sn is equal to 2 plus 0.4n. Find its initial velocity and acceleration. Let us look at this model. 122. Sn is equal to 2 plus 0.4n. 121. Sn is equal to 2 plus 0.4n. Right? So, what is the formula Sn? U plus A by 2 of 2n minus 1. Open this bracket, then you will get U minus A by 2 plus A by 2 into 2n, an. That means the coefficient of n is A. That is A is equal to 0.4 meter per second square. But remember, 2 is not U. U minus A by 2 is 2. U minus A by 2 is 2. So, U is equal to 2 plus A by 2. 0.4 by 2 is 0.2. So, 2.2 meter per second. So, when you compare this one, coefficient of n is A. So, whatever n coefficient is there, that is equal to A. This is U minus A by 2. Right? So, next 122 also. So, A is 3, U minus A by 2 is 4. So, U is equal to 4 plus 1.5, that is 5.5. So, displacement after 4 seconds is, displacement in 4 seconds is ut plus half at square. U is 5.5 into 4, 22 plus half at square. Half A is 3 by 2 into 16, that is 324. 22 plus 24, 46 meters. Next question. S1 plus S2 plus S3 plus S4 plus S10. That is total displacement. See, you can write ut plus half at square. You can write ut plus half at square. 125. If the distance covered by it in 5th and 7th, 9 seconds are 28, 36, and 44, the accelerations are. So, equate two equations. 5th second, the distance traveled is 125. A little bit calculation is required. U plus A by 2, 5th and 7th and 9th. 5th means A by 2 of 9. That is given as 28. Then U plus A by 2 of 7th second is 13. that is given as 36. Take the difference. So 28 minus 36 or 36 minus 28 is 8. So 13 by 2 times A, 9 by 2A, 4 by 2A, that is 2A. That means A is equal to 4 meter per second. So I think they asked A only. So what is the acceleration? That is 2 meter per second square, right? A particle experiences a constant acceleration for 6 seconds after starting from rest. If it travels distance as S1 in first 2 seconds, a distance S2 in next 2 seconds, and S3 in next 2 seconds, then S1 is to S2 is to S3. Actually, our S1, S2, S3 are 1 second, 2 seconds, 3 seconds. They are asking, we know that S1 is 2, S2 is 2, S3 is 2, S4 is 2, S5 is 2, S6 is equal to 1 is to odd numbers, 3 is to 5 is to 7 is to 9 is to 11. So they are saying that this is 2 seconds, this 2 seconds, this 2 seconds. Then I have to, that their new one is S1 dash is to S2 dash is to S3 dash. That means S1 is these two, S2 is these two, S3 is these two, 2 seconds. So 1 plus 3, 4 is to 5 plus 7, 12 is to 9 plus 11, 20. So if you cancel 4 again, it is nothing but 1 is to 3 is to 5 again. That means it is irrespective of the time interval. If the equal time intervals are there, the distances traveled are in the ratio 1 is to 3 is to 5. Okay? Any doubts in this one? Okay. So you have to try a little bit this fifth Roman questions. Generally, they will give two situations. So if you are taking S equal to 111, 110, 19 and 108, V square minus U square is equal to S, or V square is equal to U square plus 2AS. That means here you can say U square is 180, 2A is minus 7. From that one you can say A is equal to minus 3.5. That comparison. Here U square is 4, 2A is minus 2, A is minus 1. From that one you can find its average acceleration after 6 seconds. Here it is S equal to UT, this is 16T, plus half AT square. A by 2 is minus 2 by 3. So acceleration is minus 4 by 3. This is UT. Similarly, you can compare UT. U is 5, A by 2 is 2, so A is 4. These are comparison. Just try these questions from two friends started from same point with same constant acceleration of 5 meter per second square. Second one starts journey 5 seconds later. Here, when two situations are given, you have to consider car 1 and car 2, or friend 1 and friend 2. All related to first one, you have to write U1, A1, S1, T1, U2, A2, S2, T2. There will be a statement which relates these things. Then you can solve those things. You have to segregate. You should not write UAT. Then you will get confused whether this U belongs to first one or second one. When you are comparing two things, divide into two parts. First part you relate with the subscript U1, A1, T1. Second part U2, A2, T2. Then they will give you a statement which links these two. Try these questions. Any doubts in this one? Tomorrow we'll have the clarification. Because next one is motion under gravity. That is, as it is, the equations of motion in live situation. So mostly we'll finish the entire topic with the concept tomorrow. So wherever the topics require a more elaboration, I will go slow. Wherever the application part with calculations, a little bit fast we will cover, so that most number of topics we can cover. So most of these topics are already uploaded in the site. The basic concepts up to circular motion I uploaded last time for your seniors. So these also will cover, and we'll put these things in online. So first year are also attending, or only second year students are attending the classes?
Good evening, sir.
గుడ్ ఈవినింగ్.
ఓన్లీ సెకండ్ ఇయర్ స్టూడెంట్స్ వస్తున్నారు సార్.
సో ఫస్ట్ ఇయర్ వాళ్ళకి కూడా కొంచెం ఇన్ఫార్మ్ చేయండి ఇట్లా ప్రాక్టీస్ చేయమని.
ఎస్ సార్.
మీకు వర్క్ షీట్ కావాలంటే మోస్ట్లీ నా నెంబర్ ఉంటుంది, ఫార్వర్డ్ చేసినా పంపిస్తాను. లేదంటే విత్ ఇన్ 2 months లో ఒకసారి ఈ బుక్స్ ప్రింట్ అయిపోగానే 10 కాపీస్ పంపిస్తా క్యాంపసెస్ కి. సేమ్ వీడియోస్ సేమ్ సొల్యూషన్స్ కాబట్టి ఫాలో అవడానికి ఈజీగా ఉంటుంది. ఓకే, థ్యాంక్ యూ.